In this lesson, we are going to continue to learn how to solve rational equations. So this is Solving Rational Equations Part 2. So we will apply our understanding of solving equations to solving rational equations like we talked about in the first lesson. And then we'll also talk about checking our answer. Okay, so in this slide, I have some steps outlined that we talked about previously. These steps are for the method where you get all the denominators to the same and then let them go. But remember, another option is to multiply each denominator by the least common denominator. Okay, so first you want to make sure all your denominators are factored, because this will allow you to correctly determine the least common denominator. Then you will get common denominators. You'll let go of them, as we discussed. It's like multiplying both sides by that common denominator. And then you'll check your solutions to make sure that the denominator does not equal 0. And then just a note, some rational equations can be solved using cross multiplication, and you're only going to do that when we have one fraction equal to another fraction. Okay, so we have maybe something like a over b is equal to c over d. Nothing else being added or subtracted to that. Okay, so let's jump in and get started. Solve for x. So 2 plus 5 over x minus 6 equals 3 over x minus 6. When I work with fractions, I like to make sure everything is a fraction. And here I'm determining my least common denominator. And that is, what can you get each denominator to using multiplication? Another way is looking at what one denominator might have that the other might need. So we have x minus 6, and 1. So all of them technically have a 1. You can multiply any by 1. Our first fraction needs an x minus 6. So that is our least common denominator. Okay. So we're going to multiply the first fraction by x minus 6 over x minus 6. So this is going to give us 2 times x minus 6. And notice I put it in parentheses because the x and the negative 6 are both going to be multiplied by 2. This is over x minus 6 plus 5 over x minus 6 equals 3 over x minus 6. At this point, our denominators would cross off, or we let them go. Again, that's by taking x minus 6 to everything, and they'll cancel. And now I'm going to distribute. So we have 2x minus 12 plus 5 is equal to 3. We've got a linear equation. We know how to solve this. Let's keep going. So we have 2x minus 7 is equal to 3. We'll add 7 to both sides. So we have 2x is equal to 10. Divide both sides by 2, and we get x equals 5. Do we circle it and move on? No, we have to make sure that this does not make our denominator 0. So do a quick look. If I plug 5 minus 6, negative 1. That's okay as long as we're not dividing by 0. 5 minus 6, negative 1 again. That's okay. So really in this case, the only thing x can't be is 6. Okay, so our answer here is x minus 5. Circle it, write it down, enter it only once you've checked it. Example 2, so we have negative 2 over x plus 3 equals 8 over 5x plus 15 minus 2. So again, this does not constitute a fraction equals a fraction because we've got fraction equal fraction minus something else. Okay. With this one, we've got some negative signs to deal with, and we need to factor our denominators in order to see what our least common denominator is. So I'm going to move, when we have a negative in front, it can go to the numerator. Okay, and in this case, it's like negative 1 times 2. So this is negative 2 over x plus 3. I'm going to factor my denominator. So take out greatest common factor is always the first thing you do when you factor. So this is x plus 3, and then it's going to be, I'm going to change this to adding a negative 2 over 1. Okay, so now I can see what all of my denominators are. Now I'm able to determine the least common denominator. So when we're looking at this, what you see is all part of the least common denominator. So for instance, these have an x plus 3. This denominator needs an x plus 3. This denominator has a 5. The others are going to need a 5. So my least common denominator is 5 times x plus 3. Now what we do is we look at each fraction individually to determine what we need to multiply on the denominator, and whatever we need to multiply on the denominator, we have to multiply to the numerator. So our first fraction, the denominator needs to be multiplied by 5, so we multiply the numerator by 5. 8 over 5 times x plus 3 already has our least common denominator. Over here, we need to multiply by 5 times x plus 3, 5 times x plus 3. Okay, and so now what we have is we have 5 times negative 2 over 5 times x plus 3 equals 8 over 5 times x plus 3. And the way to read this is negative 2 times 5 times x plus 3. So what you might consider doing is just multiplying your numbers on the outside and then in the next step we'll distribute. Okay, so I just did negative 2 times 5. At this point we can let go of our denominators, and what we have now is negative 10 is equal to 8 plus negative 10x minus 30. Okay, so I'm going to go to the next slide and rewrite it real quick. Okay, so I just have a single x, so this is a linear equation, it's not x squared. So I'm going to combine my like terms on one side, and then I'm going to solve for x. So I get 12 is equal to negative 10x, divide both sides by negative 10. So we have x is equal to negative 12 over 10. And we can simplify. Both of these numbers are even, so we divide both by 2 to get x is equal to negative 6 over 5. Okay, again, it's okay to get fractions as your answers. Okay, the next one, okay, we haven't done this one yet. Solve for x. So 1 over x minus 5 minus 5 over x plus 3 is equal to 8 over x squared minus 2x minus 15. We have a rational equation. Oh, I didn't check my answer on the last one. Okay, making sure the denominator does not equal 0. The only thing our denominator can't equal is negative 3, so our solution's good to go. Okay, so we're going to factor our denominator. So in this case, x squared minus 2x minus 15, two numbers that multiply to negative 15 and add to negative 2 are negative 5 and 3. So x minus 5, x plus 3. Notice the other two denominators. Okay, sometimes this happens. And then again, I'm going to make sure that my 5 is negative, and then I'm adding. Okay, so my least common denominator here is x minus 5, x plus 3. So I'm going to start. We'll multiply this one by x plus 3. We need an x minus 5. And then the fraction to the right of the equal sign already has the least common denominator. Okay, so now I'm going to write out what I have. I have 1 times x plus 3 over x plus 3, x minus 5, plus negative 5 times x minus 5 over x minus 5, x plus 3, equals 8 over x minus 5, x plus 3. We let go of our denominators. Okay, and I'm going to multiply out at the same time. So 1 times x plus 3 is just x plus 3. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. And then we have this equal to 8. There's no x squared, so we have a linear equation. I'm going to combine like terms. So we have negative 4x plus 28 is equal to 8. So I'm going to rewrite this on the next slide. Okay, so I'm going to subtract 28 from both sides to get negative 4x is equal to negative 20. Divide both sides by negative 4 to get x is equal to 5. And remember, I didn't do a good job on the last problem. We want to make sure that this won't make any of our denominators 0. If we go back, it does. If we plug 5 in here, maybe I'll rewrite the problem so that it's clear. Here we go. 1 over, so this is the original problem I'm writing. Okay, so if we were to plug in a 5, this would be 5 minus 5, which would be 1 divided by 0. So we are not going to get a solution out of that. So in this case, our answer is no solution. Okay, let's say you were to get two numbers, 5 and 6. If 5 doesn't work, you just throw that one out. If 6 works, you would keep that one. Okay. Let's do one more example in this set. Solve for x, so 2x divided by x plus 4 plus 8 over x equals 32 over x squared plus 4x. So in order to determine our least common denominator, we factor all of our denominators. First rule of thumb in factoring is greatest common factor. If you miss greatest common factor, it is going to be very painful. Okay, so we have x times x plus 4. Look at that, x plus 4. So that's a pattern that you can keep in mind. It doesn't always turn out that way, but it's something to look for. Okay, so our least common denominator here is x times x plus 4. So our first fraction needs an x, our second fraction needs the x plus 4, And you can put this in parentheses, but just make a note that 8 needs to be multiplied to the x and the 4. Okay. So now we have x times 2x, which is 2x squared. X times x is x squared. Okay, over x times x plus 4. I'm going to distribute 8 times x. 8 times 4 is 32. This is equal to 32 over x squared, or x times x plus 4. Okay. So we can let go of our denominators, and this is what we have left. 2x squared plus 8x plus 32 equals 32. Look at what showed up. X squared. X squared. You want to start thinking of factoring square root property or quadratic formula. Okay, so we want it in the form possibly of ax squared plus bx plus c equals 0. So I'm going to subtract the 32 from both sides. And I get 2x squared plus 8x equals 0. So now I'm going to go to the next slide. First thing to look for in factoring is a greatest common factor. So both of these have a 2x. Okay, now anything that has an x gets set equal to 0 or becomes part of the solution. So we have 2x equals 0, x minus 4 equals 0. So x is 0 and 4. Before we circle this, type it in and say, let's move on. We need to check our answers. Okay, so in this case, this should be x plus 4. This was x negative 4. If we look at our original problem, which I'll rewrite here for us, if we plug in 0, we would get 0 plus 4. That's okay. But if we plug in 0 here, we're in trouble. If we plug in 0 here, we're in trouble. So 0 is not an answer. You can't divide by 0. My math teacher in high school told us we'd go to math purgatory if we divided by 0. I'm not sure if you received any such warning. Okay? Not that that's true. But anyway, that's just the seriousness. We don't divide by 0 in this class. So next, if we plug in negative 4 plus 4, 0, negative 4, and this would be 0 as well. So this also has no solution. Okay? And so when problems reach no solution, I do look to make sure that you got the answers to check, to make sure that 1, you were able to solve it in a way, and then 2, that you were checking your answer. Okay, thank you for watching. If you have any questions, feel free to reach out to me.